Alright, let's take down. Take down the first question under rate of change. The last year past question. Just take note of the question. I will explain, then we solve. You get? Now, this is the question. The question says that given that I is equals to V over R. What formula is that? Given that I is equals to V over R. Ohm's law. Yeah. Given that I is equals to V over R and V is equals to 250 volts and V is equals to 250 volts and R is equals to 50 ohms. Full stop. Determine the change in I resulting from an increase of 1 volt in V. Resulting from an increase of 1 volt in V. An increase of 0.5 ohms in R. Get the mark. Given that I is equals to V over R and V is equals to 250 volts, R equals to 50 ohms, determine the change in I resulting from an increase of 1 volt in V, resulting from an increase of 1 volt in V and an increase of 0.5 ohms in R. Are we together? Now, I said you should guess the mark assigned to this question. 6 marks. And very cheap. This is like a bonus. Give me this type of question, 6 marks. Now, from here, first thing first, before solving this question, let's understand the theory behind rate of change. Now, let's say you have this cylindrical shape. Let's say you have your cylinder. Right? From here, this is your height, right? This is your radius. Then, of course, this is volume. The maximum fluid in this cylinder, depending on the volume, that will determine what fluid this cylinder will contain. So we are saying that this should be represented as what? V. This is what? V. This should be represented as what? V, where this is the what? Height and this is the what? Radius. Now, how it works is that from here, just know at rate of change, you want to determine how the fluid will change with respect to time. Let's say you have at this bottom. Okay, let's say you have something like this. Let's say you have this O, call this the diameter of the O. Let's say 0.5 meter. This is for case 1. When this O, the diameter of this O is 0.5 meter, and case 2, just listen. From here, the diameter of this O, when it is 0.5 meter, case 1. Case 2, when the diameter is 2 meter. Now, my question for you guys is that, let's say you have fluid contained in this cylinder. The rate at which 0.5 meter diameter we release the flow of the fluid, will it be the same as the diameter being equals to 2? No. Meaning that the flow, the outflow, as it is flowing out, it is with respect to time, is it not? The time will be different. Are you getting the idea? The time will be different. Let's say that the fluid here is let's say the height rather. Okay, let me use 30 meter cube. For 0.5 meter and 2 meter, this 30 meter cube, one of them will be faster. So which one is it? Is it 0.5 or 2? 2. Comparing 2 to 0.5, the time will it be the same? No, exactly. So we want to look at the rate at which this volume will change with respect to time. Just now, that's the idea behind rate of change, at which a particular parameter is changing with respect to time. Are you getting me? At which what a particular parameter is changing with respect to time. Check that question. In this case now, we are given that I is equals to V over R. So you have to determine the rate at which I is changing with respect to time. At which I is changing. But from here, recall from your elementary mathematics, there is a relationship between V, R, and H. And that relationship is what? From geometry, SS1, SS2. There is a relationship between volume, radius, and height of a cylinder. And what's the relationship? What's pi r square h? Volume of a cylinder is equal to what? Pi r square h. We are saying that volume is equal to pi r square h. Now, you are getting there. Let me just say this. What we are doing now, we want to use the concept of partial differentiation. We've seen how partial differentiation works, right? Now, you agree with me that this V is a function of R and H. Yes or no?
Yes.
This V is a function of R and H. Meaning, if you are to determine the derivative of this case now, it becomes partial derivative of V with respect to R and partial derivative of V with respect to H. Can you see how it works? You are using the idea of partial differentiation in rate of change. Now let's interpret. From this formula, we have that V is a function of R and H. Of course, you can get the partial derivative of V with respect to R and the partial derivative of V with respect to H. And that's it. But now, since you've said you want to determine how this volume is changing with respect to time, meaning this R will be affected as well. You know, if your volume is changing, your R too is changing as well, right? Definitely your H is also what? Changing. So what we are saying is that you have from what we explained, you have that how the volume is changing with respect to time, right? This is what I want to get. Question mark. R will be affected. Yes or no? As your volume is changing, your radius too will be affected. Likewise, your height. So we are having the R, and this is how you symbolize it. What this means is that by the time this guy is changing to time, with respect to time, your radius too is either your radius is increasing or decreasing. Are you getting me? Is either your radius is increasing or decreasing, and if it is increasing or decreasing, this is how you symbolize it. Similarly, is either your H, which is your height, is what? Increasing or decreasing, and this is how you what? Symbolize it. Hope you are getting the concept. Now, from this guy here now, with what I've explained here, you know, this was the question given to us. I know that what I'm looking for here is how the current, the rate of the current, right? I'm looking for the what? The rate of the current. With what I've explained here, you know, current here now is attached to other parameters, which are what? V and R. Are you getting me? The effect on this becomes effect on this too. Meaning this one too, there will be a change in there, and the change is symbolized using the same idea. What do you have here? This sign V and what? Changing R. This is changing V and changing R. So changing V is either it was decrease or it is either it increase or decrease. Changing R, it is either what? Increase or decrease. The difference is that if it increase, it takes positive. If it decrease, it takes negative. Now check that question. Check for change in V. Is it increasing or decreasing? Increase. Increase by what? Meaning the value of this guy for that question becomes what? Positive 1 volt. Yes or no? Now check for this one. Increase by what? 0.5. The value of this is what? 0.5 ohms. Are you getting me? Now, with all this explanation, giving a question I would advise get your given that question. Surely you'll be given an equation, and we've been given that equation here from the question I equals to V over R. Now your next step, bring out your formula. Like write out your what? Formula. You writing out your formula, do you know what it means? It means you'll be able to determine the value of the unknowns, then you do substitution. Are you getting me? You are given an equation, meaning the formula. I said your next task, or first thing first, bring out a formula for the what? Rate of change. In this case now, I'm looking for the rate of change of I. So bring out the formula for the rate of change of I. So by the time you know that formula, it is that formula you work with. Then you know the unknowns that you have to get. Then after knowing them, you substitute. Hope you are getting me. Now this is how it works. From here, with what I've explained here, let's solve this equation. Okay? Before solving this equation, take note that the rate at which the volume will decrease with respect to time. The formula is are you getting me? From here, this one too will change. This guy here is changing with what? Respect to time. Normally, I would have write the v over the t, but this is the correct representation. This means it is what? Changing with respect to time. Likewise, this r and h. So from there, this is the formula, right? For this particular question, let's say this question now, you are giving parameters. The questioner says that find the rate at which the volume will change. Changing either increase or decrease. This becomes the formula. Meaning the parameter attached with it. From here, the parameter attached with this volume, they are what? R and H. That is the partial derivative of V, which is what you are looking for, with respect to R times the change in that R, plus the partial derivative of B divided by the partial derivative of the other parameter, which is what? H times the change in H. Are you getting me? Any question? No. Now with this idea, let's write the formula for this guy here. I equals to V over R. Let's write out the formula. I'm looking for, this is what I'm looking for. This is what I'm looking for. Now the formula becomes what? I want you to think. Yeah. You are an engineering student. That's what?
Partial differentiation of I
okay.
over V.
Okay.
Plus change in V.
Okay.
Plus partial differentiation of I
Okay.
over partial differentiation of R.
Okay.
Change in R.
Yeah, that's it. Correct. Now with this guy here, now I said first thing first, write out your formula. This formula now, you already know that you have 4 unknowns. Then your next task should be what? How do I get these 4 unknowns? What are the values? Now go back to your question, read your question, and you figure out the unknowns. Let's read. What do you have? Let's read again. Start again.
Given that I is equal to
Given that I equals to, this is the given equation. Given that I is equals to V over R. Okay, moving on. What do you have? Okay, giving data, right? Giving data. V is equals to 250 volts.
R equals 50 ohms.
R is equals to 50 ohms. Okay?
Determine the change in I.
Determine the change in I
Resulting from an increase of 1 volt.
resulting from an increase of 1 volt. Okay?
In volts.
I'm with you. Resulting from
An increase of 1 volt.
of 1 volt. Okay?
In volts and in VM.
Okay?
an increase of 0.5 ohms in R.
Now, meaning that from here, the value of this and this is given. True or false? True or false? True. Now, I want you, from what you've read, this value is what?
1 volt.
Negative or positive?
Positive.
Why positive?
Because it's increased.
It is increasing. If it is decreasing, takes negative. So that's it. From here, change in V is what? 1. Then change in R is what? 0.5 ohms. Come back to this general equation that is written out here. You know, you have 4 unknowns. This one, this, and this, right? From this place, you already know this and this. Yes or no? Now, you are yet to know the partial derivative of I with respect to V and the partial derivative of I with respect to R. How do we get these two partial derivatives? You what?
Differentiate I with respect to
From which equation?
I with respect to
From the given equation. Yes. From the given equation, I can get the partial derivative of I with respect to V. I can also get the partial derivative of I with respect to R. Now let's solve. Now I want to see how good you are when it comes to differentiation. Let's solve. I is equals to V over R. Your partial derivative of I, you know what partial derivative means now? If you are solving partial derivative of I with respect to R, take anything that has to do with R as constant. Your interest should be what? V. Now solve. What will be your partial derivative here? Why do you want over R? Wait. That's, I don't know if that is correct, but are you sure about what you are telling me? I need a chorus answer now. 1 over R square. You what over?
1 over.
Yep. 1 over. Now I'm having different answer. I'm having 1 over R. I'm having 1 over R square. I'm having 2R. Which one again?
1 over R.
1 over R.
Yes.
Correct.
Correct.
You are sure about that?
Yes.
You are telling me that the partial derivative of I with respect to V is what?
1 over R.
Okay. I don't know if it is correct or not. You will see that later. Now, write down partial derivative of I with respect to R. That will be what? We are level now. You should be able to determine any derivative. Because this is what you did throughout year 1, second semester.
Minus V R
Okay.
raised to power minus 2.
Minus VR dot R raised to power minus 2. Any other answer? Work it out now. It's something you can work out. Work out. This is the given question. Yeah, you want to get partial derivative of I with respect to R and partial derivative of I with respect to R. Is what? Okay. To save time. Let's solve it out. Then we have you know, and even this question is given directly to be I equals to V over R raised to power 2. Partial derivative of I with respect to V will be what? I with respect to V will be what? I with respect to R will be what? 2RV. Now, I can see that the condition is this division. Yes or no? That's the condition. If you can do this, then what's this? Now, what it means is that whenever you are given any question, not only differentiation, any question, try to relate. Now, let's continue. It was just an assumption made. I'm trying to say that if you can tell me this answer correctly, then what's this? You should be able to do it then. Now, what I'm trying to say is that any question, wherever the question might be, if it is technical, if it is an advanced question, try to bring that question to your level, to what you are familiar with, to what you can relate to. You know, it's because you understand this one, that's why you were able to tell me the answer correctly. Meaning this question, relate this question to something like this. Or first, let me ask you, if this question, if you interpret it to something like this, definitely you'll be able to tell me the answer correctly, without doubt. right? You are sure about this is your answer, there's no if it is correct or not. Now to do that, this given question, try to relate it to this question. Write this question in this format. That would what?
V r raised power minus 1.
I is equals to v dot r raised to power minus 1. Now, meaning that this given question implies that v is equals to I is equals to v dot r raised to power minus 1. Now, so compute this answer and this. What do you have? Okay? For this first one, what do you have? 1 over r. Then for this one, what do you have? Minus v dot r minus 2. In fraction, meaning minus v over r squared. Yes or no?
Yes.
1 over x. No. If we integrate 1 over x, that means x. Yeah. If we integrate 1 over x, you get the x. Now, this answer now, me asking that, are you sure it's 1 over r? Are you sure it's negative b over r squared? What will be your response?
Yes.
You are very sure, perfectly sure. You get. So what I'm trying to say is that whenever you are given a question that looks advanced or complex, try to bring it to your level, to what you understand. And that's what we've just done here. Now, from here, what it means is that your partial derivative of I divided by partial derivative of b is equals to 1 over r, right? Then your partial derivative of I with respect to r is equals to negative v over r squared. Now, we know the answer to this in terms of r, in terms of variable. Likewise, this we know it in terms of b and r, in terms of variable as well. But we want to get, from here, the decrease of, definitely is either I increase or decrease, and that will determine the rate at which I is changing. To do that, you end up having a value. You estimate the value. You get, meaning numbers are not terms, are not expression. You get, at the end, this guy here must be equal to a particular number, either 0.4, 0.5, 0.1 and the likes. Now from here, what it means is that you need to know the value of this, the exact value, the number for this. This is it in terms of variable. Then how do you know the value? How do you get the value? We've been given, because from the question r is given to be 50. So to compute this value here, it means 1 divided by 50. What about this one? To compute this value, it means negative 250 divided by 50 squared. Now let's solve. This implies that 1 over 50, and that's 1 over, what's the value of r given from the question? That's divided by 50, and this is what? 0.02, right?
Yes.
Now let's stop. Let's get the value of partial di divided by partial dr. We've solved this earlier. We got negative v over r squared. Substituting the value of v and r given from the question, it implies that negative 250 over 50 squared, meaning 50 times 50, and that's what? 2500. This cancel this, right? What do you have? Negative 25 divided by 250, and this is what? Minus 0.1. Now from here, you've been able to calculate the value of partial derivative of I with respect to v as 0.02. Anywhere you see partial derivative of I with respect to v, what are you going to substitute? 0.02. What's the value of this given from the question? 1. Moving on, partial derivative of I with respect to r, you solve that to be negative 0.1. Anywhere you see this, what will you substitute here? Negative 0.1 times the decrease, the rate at which r decrease is what? Sorry, in this case r is increasing, so the rate at which it increased given from the question, what do you have? 0.5. Now let's do our substitution, meaning that the rate at which I, we don't know yet, either decrease or decrease. Let's substitute our answer. That's what, open bracket 0.02 all into bracket 1 plus open bracket negative, okay, 0.5. Then from here 0.02 negative 0.05. The subtraction of this gives us what? Minus 0.03. Now answer that question. The rate at which I is changing, is it increasing or decreasing? Decreasing. Why is it decreasing? Because what? Yeah, say something now. Yeah, from there, what we got here, we got negative 0.03. Now my question is I increasing or decreasing? Decreasing. Yes. This negative shows that I is decreasing. In conclusion, what you are going to write is that, you write the rate at which I is changing with respect to time is 0.03. Open bracket, decreasing. Because of you got a negative answer, minus what do you say? Exactly, the negative is showing that it is decreasing, but the magnitude is 0.03. So this is the idea on rate of change. This is how rate of change works. So I'm going to send question for you guys to solve. I'll drop it on the group. So a similar question to this, though that question is more like this one. This is the formula. The formula for this pi r square, that's what you are going to use to solve. So that's how rate of change works.